This is our thermal detection system prototype. We have a thermal sensor which is mounted in the cap on top. You see a little flag on the top. Inside the casing of the pod we have a stepper motor. We have a control board, and then we have software that takes the data and presents it in a way that's a little more organized so people can understand what we're looking at. Now in a moment what I'm going to do is I'm going to introduce a cold spot, but I want to try to describe what's actually happening here. The sensor itself is an 8x1 segment linear thermal sensor. Each segment is about 6 degrees wide on the horizontal, and the total spread at this distance is about 63 degrees. So we're looking at an area of approximately 6 to 7 feet tall from the floor, from the concrete up. And then the stepper motor controls how far or how much of an angle the device will sweep. And you can control that and adjust it from 1 degree up to 360 degrees. You can also control the resolution. The sampling rate of the sensor itself is one sample every 250 milliseconds, so we're getting about 4 samples per second. Now that data is being compiled and presented through software on a screen. The particular mode that I have this configured for at this time is what we're going to do is we're going to do the first sweep that it does over 50 degrees. I have it set for 50. It's going to learn all the characteristics, each 6-degree step that it takes. In this case that's the viewing angle, but each step of the stepper is 1 degree. We're going to take measurement data and we're going to learn the pattern of all the temperatures within the field of view. And then what we're going to do is all the other sweeps that we do are going to be compared to the first. So really what we're looking for is a deviation that occurs after the first sweep. And that deviation is going to be that right there, ice pack. We're going to throw that out there in a moment. So let's start it up and I'll show you what the screen looks like. We're going to do a total of 20 sweeps. You can see this thing moving. You can see the display filling in. All right, it's learned all the temperature variations. Now, it's going to continue to sweep for about 20 sweeps. The variations that I'm seeing on the screen, which may not be in fine detail on this video, is about plus or minus 0.5 degrees. All right, those can be anything. Air currents, I've got a fan up above, we have lights, we have concrete, which is cool. One of the things that I had to do was I had to measure what the concrete was through this device, and then I had to make some adjustments so I ignore that. But that's what the sweep is doing for us right now. All right, we're going to sweep. Let's introduce this ice pack, and I'll show you what the image looks like. So we're going to come over here, put that there, come back. Don't mean to move the camera so fast. Let's take a look. There it is, right there. You can see that blue blob. That's the ice pack. Alright, so again what we did was we learned all the temperature variations within the swing, or the amount of sweep that we have here during each scan is 50 degrees. We learn all the temperature patterns within that sweep, and you can do that up to 360 degrees if you like. And then we look for change. And we've just completed our 20 sweeps. Now, just for kicks, I can go in and connect all the dots and animate that. Now watch what happens. There's the blue. Now you may see, if you look carefully, you'll see me entering the screen on the right side. The red, that's me coming in and putting the bottle in place, the ice pack. Okay, so now all this data is saved. You can analyze it using Excel, or you can create a little video of what actually happens in the environment. There you go. Now I can also adjust this to ignore my heat signature completely if I like, but it's kind of cool to be able to see the actual change once you take all the measurements throughout the 50-degree viewing angle. All right, that's all I want to show.